Good morning, everyone. Mr. Cray back in business again, making videos, getting ready for our first day of school back from the holiday break. I hope you had a good holiday break. Today's and the next 3 weeks focus is going to be on graphing. And so we're going to start with linear graphing and just looking at the overall aspects of that and just trying to get an understanding of that. It's mostly review. And then on Thursday and Friday classes, we're going to start doing more of like rate of change and start really looking to numbers of a graph and the linear portions of that as well. Okay. All right, great. So let's start first. Let's talk about the little coordinate plane. So we have here, this little white thing in the middle is called the coordinate plane. This is what the graph would be on. Now, mostly you would be dealing with in the graphs we have, you're going to be dealing quadrant one stuff here, all right, the one I just checked off, which is basically means that the x and the y axis are going to be positive. So if you don't know, then that horizontal spot line that goes here is the x axis, and the vertical line is called the y axis. And the coordinate plane has four different quadrants. That's quadrant one, which we mostly going to be working with doing our little situations and things like that. There's going to be quadrant two, quadrant three, and quadrant four. Okay, and so each quadrant has like different properties that the x and the y value of the coordinate points have different values of a negative and positive. And that's what we use that for. Okay, so let's talk about a couple of things inside this coordinate plane. So number one is what about the point in the middle here? Right in the middle here. That is called the origin. Okay, that's called the origin. Okay. All right. I'm going fast here because I think most people would know this stuff, but just to make sure. Okay. That's called the origin. So the origin is where it originally starts, and that's where we usually start from to count your coordinate points. Okay. So, and that has a coordinate value of 0, 0. Okay. All times 0, 0. Okay. Because there's no x and y value, but that's where the middle start point is. Okay. So that's the big one. Now, if I wanted to plot some points and make a line here, okay, let me pick up some points and put them in each category here. So this is one point right here, okay? So this little dot is a point. So how do I make a coordinate point from here to here? So think about it, okay? So if I have the x-axis, how many spaces in the x-axis I have to go to the right to get to that point? So I have 1, 2, 3, okay, that'd be 3. And I go up, how many spaces? 1, 2, 3, 4, 5. Okay, so the coordinate point for this one would be 3, 5. And that's how it would work. So I basically put the coordinate point just like this, 3, comma, 5. And it would be in the x and y. So the 3 would be the x, and the y would be the 5. I think we all know that. Okay, so let's do another one on the other side here. So let me do this point right here. Okay, so if I do that point, all right, I'll make it 1, 2, 3, 4, 5, 6. Okay, so that would be negative 6 because it goes to the left, positive 6 to the right, negative 6 to the left. 1, 2, 3, 4, 5. And I go up 5, so that would be negative 6. Coordinate point with negative 6 and positive 5. Okay, boom. Okay, and that's all we'd put down. So we'd put down negative 6, coordinate point negative 6, positive 5. Okay, I think we get the idea of making a quadrant point at this point. All right, so let's start looking at some other situations that you possibly could see. So what if we have right on this vertical line here? Oops, sorry. Okay, all right. So what if we have right on this vertical line? So say if I have a point, whoa, sorry guys, whoa. Sometimes it has a mind of its own. Sometimes it has a mind of its own. Yeah. Come on. I had a great start here. That's better. There you go. Sorry about that. Sometimes it has a mind of its own. There you go. I don't know why it's like that. All right. So, uh, all right. So, moving on. Sorry about that technical difficulties, guys. All right. So, what if it's on this line right here? Okay, right here on this line. Okay. So, if it's on a line, okay, this would be what we call the y-intercept. So, again, with the origin would be still at 0 because it's right on the line of 0, the x. Okay, but the y we'd still count down. 1, 2, 3, 4, 5, 6, 7. Okay, so that would be 0. Ah, I lost it. I won't let me write anymore. Oh, there we go. Okay. All right, so it is working. It wasn't working for a second. All right. Sorry about that, guys. This thing has a mind of its own today. All right. So again, this would be 0. Okay. -7. All right. So what's special about that point? So let me put that down there. 0, -7. All right. So since it's on the x-axis. Okay. Since this is on the x-axis, this would be technically called the y-intercept. Okay. All right, so that's an important spot if you understand it. So if the line is on, or the point of the line is on the y-axis, it's called the y-intercept. So that's a good point to know. All right, so when we start to get really involved in here, we're basically going to know, okay, we got the equation, we're going to know what the y-intercept is, and that's basically going to tell us exactly how to graph the line. Okay, so we need to know that. Now, if it's on the x-axis here, let's say we got this point on the x-axis, same thing. The y would be a 0 because, again, it's stay on the same line, but then we count over how many spaces x. 1, 2, 3, 4, 5, 6, 7, 8. So this would be -8, and this would be 0. Okay, and that would be the x-intercept. Okay. So those are important points. X-intercept to y-intercept. Now, you're mostly going to use the x-intercept more than you're going to use the y-intercept, and more you're going to use the x-intercept. Okay, so that's going to be the big one that you're going to be using to graph it. Okay, the x-intercept is kind of like one of those things that we have just in case if we say we have when you start to get into harder ones like exponents and like lines that you go to x to the third and all that kind of stuff. So it gives you kind of points. So that's basically it. Okay, making sure you understand the different points of the graph here. All right, you have the coordinate plane, you have the different quadrants, you have the x and y axis, you have all the coordinate points, and make sure that you know that if it's on the line, it's going to be the y-intercept or the x-intercept, depending if it's vertical or horizontal. All right. So moving on, let's get to some more harder stuff. Okay. So here's a line. Okay. Now what we're going to do is basically we're going to pick some coordinate points. We're going to plot them. Okay. And then we're going to put them in this little table over here. So this line is going to be continuous because it has 2 arrows on each side. Okay. So that's a continuous line. This is a linear line. And we'll talk about when we get later on. We'll start talking about the correlation of the line and how that line is going. It's a positive and negative. Okay, that's where we're going to end up going. All right. So let's pick some points and talk about them. Okay. So let's talk about this first point right have here. All right. So this would be, what do we call this? Because remember, this is the y-axis here. Okay. And remember, this is the x-axis on the bottom. So we have the x-axis and we have the y-axis. I might call it the y-axis because I don't want to write it all out. Okay. All right. So we have this point here. Now it's right on the vertical line. So we're going to call this the y-intercept. So all we have to do is count how many spaces up, because we know it's 0 for the x-axis. 1, 2, 3, 4. So that's 4. 0, 4. Okay, 0, 4. So that would be the first one. So let me put a coordinate point of 0, 4 here. Okay, let me pick another one. So again, start looking for ones that where the lines meet. Okay, so this one right here is another good one. All right, so that one is 1, 2, and up 1. So that would be 2, 1. So that would be another coordinate point that I pick. So that would be 2, comma 1. All right, so let me look at another point. This one right here that I had already done. Okay, so how many places I count over? 1, 2, 3, 4, and I go down 2. So that would be 4, negative 2. Okay, so remember, because if you go downwards on the y-axis, this is negative. If you go to the left on the x-axis, this is negative as well. So that would be 4, negative 2. Okay, and let me get another one from the top here on this side. So I'm going to take this one right here. All right, that one's a good point. So again, you want to look for ones where it makes the boxes or the end of the corners of the boxes. Okay, that's the best one to do. So let's see, you go 1, 2, and we go 1, 2, 3, 4, 5, 6, 7. Yeah, 4. No, we got actually 6. So this is let's see, 2, 6, negative 2, 6. Yeah, let me get this 2 in here. Sorry, guys. Negative 2, 6. Okay, so those are the quadrant points that we have here. So we put negative 2, and then we put 6. Okay, those are the quadrant points. So what we do with these quadrant points is we can actually put these in the table. Okay, so the x is going to be the independent variable that's on the x-axis, and the y is going to be the dependent variable. So basically what we're saying is that if we plug in a value of 0 into the equation, okay, the output is going to be 4. So we plug in 2 into the equation, the output is going to be 1. If we plug in 4 into the equation, the output's going to be negative 2. And if we plug in negative 2 to the equation, 6 is going to be the output. Okay. So again, what happens is then what we'll do later on is we'll start looking at this table and see if we can determine a pattern. And then once we determine a pattern, then we can take that and actually make the equation off that. So there's a bunch of ways to do this. This is like basically very I don't say flexible, and how you actually get your information. So there's going to be mad ways to get your equation. There's going to be mad ways to actually take the equation and actually make the graph. And then you have so many different ways to do other things as well. Okay, and get some information from a graph. That's why a graph is so critical and so important to do in 7th and 8th grade, because again, you're going to use that all the way up until the end of high school, these graphs. Okay, so again, we just talked about coordinate points. All right, taking the coordinate points, making them on the line, and then obviously put them into the table, and that's what you will have to do today for class, and some things like that. Okay. All right, I think we get that. So let's move on and get some little harder stuff. All right, so did a little harder problem here. Let me see if I can make it. If I can write on this here. Uh-oh, it's giving me a hard time about writing again. No, I don't think I'm going to be able to do that. Oh, there we go. Cool. I got it. All right, so let's look at this. Okay, so we have here's a verbal statement here, and this is something that we're going to be getting to as we go along in the process. So Sarah has 2 baseball cards. Each day she collects 3 more cards. Okay, so we have an equation, we have a graph, and we have a table. So today's most focus is we're going to be able to take this table and make a graph from that, and based on this verbal statement. Okay, so what do we know about this verbal statement? Okay, yeah, we know that Sarah has 2 baseball cards initially, and each day she collects 3 more cards. Okay, so let's think about it here. So let's label the table and figure this out. So we know this is going to be the X, this is going to be the Y. Okay, we know those two. Now, what is the X in this situation? Okay, the X, if you think about it, is the baseball cards. So I'm going to put BC for baseball cards. I'm not going to write the whole thing out. Okay, that would be X value. Okay. Oh, actually, I'm sorry. My fault. That's not the X value. Take that away. I always have been doing this stuff backwards. Okay, so let's see, the Y value is basically going to be the baseball cards because at the end, she wants to know how many baseball cards she collected. Okay, so that's the baseball. Now, the X value is going to be so that would be the dependent. So whatever, so something makes her get all her baseball cards. Okay, and so let's think about it. Each day she collects 3 more cards. So the X value would be day. Okay, the time. All right. So again, if you have issues with that, just think about the independent variable be something that can be done without having some kind of input to happen. Okay. So the days is always can change, even though if you don't get any baseball cards. So that's something that's why it's an independent variable. Okay. And the baseball cards would be the Y. So at the first day, she has 2 baseball cards. Okay. She just has 2. Okay. What about the second day? I mean, the first, and when she starts, the first day, each day she collects 3, so she's going to have 5 baseball cards now. Okay. And the second day, she's going to have 3 more, so she'll have 8. Okay. And the next day, she's going to have how many? 8, 3 more, that she'll have 11. Okay. So that's important information I got there just by basically looking at that. All right. So then what I could do is I have this table here, and I could take these tables as coordinate points, and I can graph them. Okay, so this would be, so we have a 0, 2, so that would be our x-intercept. So we go up 2, and there's 1 point right here. Boom, there's our 0, 2. Then we have 1, 5, so then I go over 1 to the right because it's the x-axis, up 5. 1, 2, 3, 4, 5. Boom, right there. Okay, then the next one is 2, 8. So I go over 2, and I go up 8. That's going to bring me probably somewhere around here. Yeah, somewhere around here. Sorry, guys. And then the last one is 311, and that's going to be out the door. But like I said, this would be the actual line, if I can do it, of the graph right here. All right, linear graph. Whoa, that's a long one. All right, let's go. All right, so that would be the line of the linear graph based on the table I just made. So you can make the table, you can make the graph. Okay, you just got to be able to determine what's the x and y. If you can do that, you're good. Now, here's the hard stuff that we're going to be trying to do on Thursday and Friday. We're basically going to have this verbal statement. Now we got to turn it into an equation. Okay. So think about it. We said the Y is going to be the baseball cards, right? Now, what is the X value here? What's going to be the X? The X is going to be the days, right? So she gets 3 cards every day. So she gets 3 cards per day. So that would be, so it would be 3, if I can make the 3, X. Okay, because she gets 3 times the amount of days, she gets 3 cards per day. Okay, and then she started with 2, so that would be our 2, and that'd be plus 2. Okay, I think we get it. 3 plus 2, so 3x plus 2 would be the equation. Now, what is the initial value? So this is something that we're going to be working on. This initial value also means y-intercept. Where does it cross the y-axis? Okay, where is initial value always going to be? You know, the x is going to be gone and just going to have this constant value in the back. Okay, so the initial value is just going to be 2. Okay, that's going to be 2. Okay, because again, this little value, this b value, we'll talk more about this as we go along, is going to be the value that tells us, well, the y-intercept. Now, the rate of change is another thing. What is going to be the change? So every day, what is it changing by? Okay, so if you think about it, okay, 3 times x. So whatever, how many days, you're going to get 3 more cards. So the rate of change is going to be 3. Okay, so the rate of change is also called the slope. Okay, and we'll start talking more about that as we go along in the process of exactly how to get that information. But right now, we basically look at the equation and look at the value next in front of the x, and that was going to give us the value of the rate of change. Okay, so again, that's how you would do a problem like this. Is basically, you know, is the equation, initial value, and find the rate of change. So we're going to start talking about problems like that as we go along in the process of this Thursday and Fridays and in other classes. Okay, so again, if you're able today, you're able to take the table, make a graph, you're good. If you can do the equation, that's even better. But you're going to be ahead of the game. But I'm mostly concerned about today is making sure that you're able to take the table, make a coordinate grid, and then be able to graph that information. If you can do that, you're golden today. All right. All right. So that's it for today for class, guys. Just make sure that you're able to do that. And like I said, we will carry on later on. Peace now.